So doing an E2 reaction, so calling it out, reactive base, negative charge. Because it's reactive, I already know it's E2. I'm not worrying about SN2 in this case because this is actually a tertiary alkyl halide. So I know it's E2. Gotta identify the beta hydrogens. So draw all those in. Beta hydrogens, of course, this is the alpha carbon. Beta is one bond away. Beta, beta. So I see 5 total. I see 5 total, but I see just 2 types. Right? There's some symmetry here, both the ethyls versus isopropyl. So how do I choose which one's possible? So remember, in an elimination reaction, you're going to eliminate 2 things, a hydrogen, a leaving group. I want to make the most stable product, which is going to be the most substituted product by Zaitsev's rule. So that will be taking hydrogen B. I know that because I could just draw it out and realize it. Or I could look at it and say, well, there's only one B. So the carbon that B is bonded to, the beta carbon here, must be more substituted because there's only one H. And so that would lead to the more substituted product. Do the E2 reaction. 3 arrows. That would lead to E2. The pi bond is there. Did not number my carbons, should have. They're in between there. There's the methyls. There's hydrogens A, both there. They did not get eliminated. Of course, the other product is this. So great, that's done. There is an exception to this rule. Of course, this is the Zaitsev product, tetrasubstitute. We would have grabbed hydrogen A, however, if I shrink that down, if our base had been much larger, right, like a terbutoxide, then it's going to be tougher to grab B because this is a tertiary alkyl halide, and now we have a really big bulky base. So we might get some of A. And that would be, mechanism doesn't change. That would be this. Something like that. Nope, that's wrong. This is the way you should number your carbons. There you go. That'd be the possible product if you use really bulky base with a tertiary alkyl halide. Right, so the key factor is sterics. So tertiary means there's a lot of carbons around this leaving group. And because B is also bonded to 2 carbons, there's only one H there, it actually makes it harder to get to that. So the double factor, tertiary alkyl halide, really bulky, charged base, makes the non-Zaitsev, or in this case the tri, instead of the more stable tetrasubstitute possible. So it's really about sterics, right?